Hello, Algebra 1. We're going to finish up this section. Um, Now that we've looked at a system of inequalities, we're going to start graphing them together and coming up with solutions. So there's three situations here that we're going to look at. We're going to look at two of them whenever you try one of them on your own, but they're all pretty similar. We're going to write a system of inequalities, graph it on Desmos, and then use that graph to identify a solution. So the first one involves bank accounts. A customer opens a checking account and a savings account at a bank. They will deposit a maximum of $600, some into checking and some into savings. They might not deposit all of it and keep some money as cash. The bank also requires a minimum balance of $50 in the savings account. It doesn't matter how much money is kept in the checking account. Write a system of inequalities to represent the situations. Specify what each variable represents. So in this case, we're depositing money into an account. We just don't know how much money it is. But we know there's two accounts. There's a checkings account and a savings account. So that's going to be my X and Y. So I'm going to let X be my checkings account. And Y is going to be my savings deposit. Now I'm told that I'm going to put a maximum of $600 into the two accounts put together. So if I take the amount I put in my checkings account and the amount I put in my savings account and add them up, that cannot go over $600. So that's got to be less than or equal to 600. Now we also know that the bank requires a minimum balance of $50 in the savings account. So my savings account, I can't put nothing in there. To hold that account, they need you to have at least $50 on there. So the amount in my savings account has to be greater than or equal to $50. So we're going to grab this on Desmos, find a solution, and I'm also going to insert a picture of the graph right here on the side. So if I open up Desmos, I already have these two inequalities written down. We have to zoom out. Oh, so it's going to look something like this. So anywhere in this green area is making sure I deposit $600 or less. Anything in this purple area is making sure I have at least $50 in my checkings account. So if I want to have both of those going on, I need to be kind of in this purple triangle area where I'm above the $50 threshold and then I'm within my $600 total. Now remember on Desmos, you can actually add labels for the x-axis. So I can make my x checking and y savings. And again, you don't have to do this, but it's a good way to kind of see what's going on here. So now when I go to share graph, I'm going to export image. You can keep the lines, then you can make them thick or thick with two C's. Either way, we're going to copy image. And then just right here on the side, I'm just going to right click and paste. Now you can move it so it looks kind of fits the way you want it to fit. I like to set it as background so it doesn't move. Move it a little bit over. You don't have to do this part, but I just don't like moving it when I don't want it to move. So to find a solution on the graph, it's anywhere that's below this green line, but above this purple line. Like I said, it's in this region, the solution set right here. So for example, this point right here, which looks like it's 100, 1, 2, comma 300. So 100, 300 would be a solution. Now we're asked to explain what these numbers represent, and 100 represents the amount of money we're depositing into the checking account. $300 represents the amount deposited in the savings account. And they are a solution to this system of equations because we see that it's in that solution region, that shaded region. All right? And that's all that we're really doing with these inequalities here. So let's look at another example where we go to a nice fun concert. Perhaps another Taylor Swift showing. Okay, so at concert tickets, two kinds of tickets to an outdoor concert were sold. There's lawn tickets and seat tickets. Fewer than 400 tickets in total were sold. Lawn tickets cost $30 each, and seat tickets cost $50 each. The organizers want to make at least $14,000 from ticket sales. So we want to write a system of inequalities to represent the situation and specify what each variable represents. So in this case, we're selling tickets, and we want to sell no more than 400, but we want to make at least 14 grand. We don't know how many tickets we're selling. So I'll let my lawn tickets be X and my seat tickets be Y. Now we're going to sell fewer than 400. Maybe there's like a max capacity, and so we don't want to have more than 400 people there. So if I take the amount of lawn tickets I sell and the amount of seat tickets I sell and add them together, that number has to be under 400. Now, each lawn ticket costs $30 each. So I'm going to make $30 times however many lawn tickets I sell in just the lawn seats. The seat tickets cost $50 each, so I'm going to make $50 for each seat ticket I sell. If I add those two together, that's how much money I'm making from both tickets, and that has to be at least $14,000. So it's got to be greater than or equal to that value. So now we're going to go on Desmos, find a solution, and insert the graph over here on the side. So if you get on Desmos, again, pause the video if you need time to do this. Don't feel like you don't need to pause the video. Here's the system of inequalities that represents the situation just mentioned. Although X is now the lawn tickets, and the Y is now the seat tickets. So in the situation here, anything under this dashed line is a solution. Now it's a dashed line, so we can't be on that because any point on that would be selling exactly 400. We want to sell under 400. And again, we can't sell negative tickets, so we really just want to be in this right triangle here. Now, to be in our sales constraint, we want to be in this pink area here. So to be a system to the to be a solution to the system of inequalities, we need to be kind of in this sliver here where there's a little bit of an overlap. So any point in there is going to be a solution. So looks like the point, this looks like it's going by 50. So 50 comma 300 looks like it's just going to be a solution. Let me do that. 50 comma. So I'm going to put that point in there. And let's see if we can export this image. Right click copy. Right click pasta. I like to set as background. So that point right there, which I said it was 5,300, yep, is going to be a solution. What does the 15,300 represent? 50 represents the amount of lawn tickets. 300 represents the amount of seat tickets in order to make at least $14,000. But still sell fewer than 400 total tickets. Must have been a then. Anyway, so that's it. So what I'd like you guys to try doing is try looking at situation 3. It's going to be very similar to situation 2, looking at advertisement packages. And then once you finish that, you have the cooldown down here. And that's what I'm going to check. And then if you guys finish that early, I'd like you guys to start the homework. So the homework I should be getting assigned around 12:20. And I'm going to ask Mr. Ryan to drop off copies so that you guys can do it on paper if you prefer that. Anyways, have a great day. Make sure to like, share, and subscribe. Ring the bell for notifications. And smash that thumbs up button. Go Lancers.